Okay, hello everyone. So today we'll just look at our day 3 practice about half model. We will come into our geometry model section, and I think the half model is a very important thing in the NEMOS. And you can see every year at least they will test one or two questions based on this. So I think this is the most important part in the geometry, and also you need not only you need to remember all the models or the basic half models, and also sometimes you need to do some change, right? So sometimes the question will just not give you a kind of model that you can find in your brain, and sometimes you need to do some change, then you can find, okay, so actually it's one part plus another part, okay, build this half. And also, yeah, maybe sometimes you can find two triangles, they have the same area, so you can just transfer it. Okay, so before we look at the half model, we need to understand a new things. Actually, it's not a new things. So in math, we have some conclusion, right? So you don't need to prove that, but you have to remember that. For example, now I have two lines. Okay, I have two lines. There are two parallel lines. So we can see this L1 and L2. So we can see L1 is parallel to L2. So we have a rule is that between the two parallel line, the distance won't change. The distance won't change like that. Okay, so the distance won't change. That means no matter how I choose one point and I draw the perpendicular line to another line too. No, if I randomly choose another point and I draw a perpendicular line here. Okay, so this length, for example, h, is always same as this part, h. So that means the distance between two parallel lines won't change. Okay, so this is the first very important things. And so now why we need to learn that for the half model? Because you know half model is like in a parallelogram or something. Yes, maybe the rectangle, because rectangle is also a part of the parallelogram. So we have some same areas, right? Okay, so before we look at that, so let me just random draw triangle inside here. Okay, so I see this is A, this is B, and this is C. Right? So yeah, if I tell you the height, okay, so the height of this triangle I can draw here between these two parallel lines is h. So can you tell me how to calculate the area of this triangle ABC? The area of triangle ABC, it should be the base times height, then divided by 2. It should become BC times small h over 2. So this is the triangle ABC's area. This is the triangle ABC's area. Now let's do some change, okay? So if I move this point A, you mean to this point, for example, let's name it A prime. And now if I connect this B, A prime, and A prime C. So maybe I can move further. So this place A prime prime, if I connect this BC, B A prime prime and A prime prime C. So now, can you tell me how to calculate triangle A prime BC's area? So as you can see, what is the height of A prime ABC? It's still this height, right? What is the length of this height? Still h. And how about the height of A prime prime BC, this triangle? Yes, the height is also here equals to h. That means if I want to calculate the area, that means BC is still BC times h divided by 2. And this triangle A prime prime BC's area is also BC times h over 2. Okay, so this is about the things if we find out several triangles between the two parallel lines. If we set the base not change, the other point move on this parallel line, so the area won't change. We have easily proved that. Okay, so that means between we have two parallel lines, so you can randomly move the third point and you just keep the base not change. The area won't change. Okay, so now let's look at another one. So now let's move here to the parallelogram. So this is a kind of parallelogram. It's a little big, but we just keep here, okay? So this is the parallelogram. So because of the half model, right? So let's talk about some area. Okay, some maybe area, some triangle is just the half of this parallelogram. So the first one, of course, you should remember, is just if I connect the diagonal line. If I connect the diagonal line, actually I separate this parallelogram into half. So this shaded area is half of the parallelogram. This shaded area is half of the parallelogram. Now let's think about another one. So let me copy something. Okay, if I have the same parallelogram here, so you can see if I connect the diagonal line, it will be half of the parallelogram. But now this time, look at this picture. If I choose this point, I keep the base not change, this red line not change. I move this red point maybe sometimes to here, right? So for example, now the triangle will become like that. Okay, like that. So this one, is the same as the previous one? Yes, we never change the area. That means this red part, okay, is also a kind of half model. It's also a kind of half model. So we call this one is like the mountain. It's like the small mountain, like here, right? You can climb the mountain. So it's like the mountain inside the parallelogram. So this is half of the parallelogram. What else? What else? Also, this red point we can move to where? Maybe we can try to move outside this parallelogram. It's just on this parallel line. So we can extend this parallel line maybe to this place, right? So if I connect here, so this orange part, yes, is also a kind of parallel line. Half model. It's also a kind of half model. So what else? What else? Let me copy this one. Okay, let me copy this one. So if I clean this part, for example, if I clean this one, like the mountain, right? So we just keep the mountain here. So can you find any other parallel line? So because remember, our rule is if we keep the base not change, we just move the other point in this parallel line, the area won't change. So we can draw another parallel line, like here. We can draw a parallel line which parallel to the other side of this parallelogram. So that means this red point, okay, I can just randomly move, right? I can just randomly move to here, for example. So now, that means for this parallel line, I separate this parallelogram into two small parallelograms. So this, I can see, is just the half of the right parallelogram. And this part is half of the left parallelogram, right? It's a half of the left parallelogram. So here, we can just move this red point to this place. And after that, if I connect this part, you can see I have two small mountains inside this two small parallelogram, right? I have two small mountains. So I can just clean this part, clean this part. So here, the green part is also a kind of half model. It's also a kind of half model, okay? So yeah, actually, this one, we have another conclusion, is that inside any parallelogram, okay? If I randomly draw a parallelogram and I randomly choose one point inside this parallelogram, and then I connect to the four vertices, okay, like here. So you can see this green part, the sum of these two green parts triangles area is same as the sum of this red parts area. Is also equals to half. We can easily prove that. How to prove? We just move this point to here, right? And it will be same as this part, okay? So that means the conclusion is the top plus bottom equals to left plus right. equals to half. Okay, so this is also a kind of parallelogram, half model inside the parallelogram. And what else? Okay, so maybe we just base on this diagram. Okay, we base on this diagram. Let's put here. So now remember, this time I move the red point from top, from the on the line of the parallel line to inside the diagram. But what if I move this point outside the parallel line? Is it okay? Yes. If I move the line to here, okay, I move the point to here. So now there is no more this green part. Let me clean it. So if I move to the top, you can find, actually, I can just connect still connect this part. Okay, I connect to 4 vertices, like here. So now, how about this green part? Just tell me, do I ever change the base? Do I change the base of this? Sorry, this maybe, do I change the base of this one and this one? Of this part and this part? No, we never change. And do I change the point from the parallel line? Also no. That means the height is also the same, right? If I want to draw the height, it should be like here. The height also not change. That means in this diagram, even this point is outside the parallelogram. Okay, you can see this green part is also a kind of half model. It's half of the parallelogram. Okay, so what else? What else? We also have other things. So maybe we just base on this part. Okay, we just base on this part. So now let's move to this place. And you can find, if I just draw a mountain here, I have a mountain. So I clean all the things. So now, if the diagram is like here, if I firstly cut it into some part, I randomly draw a new parallel line. And this line is parallel to the both top and bottom one. So now let me clean it. So this time, if I draw like here, like the dog teeth, okay, maybe I just random draw like here, like here, like here, okay, this part. So what is the shaded area? Okay, so what is the shaded area? So as you can see, for this part, I have the purple one. The base, what is the sum of the base of all these 4 triangles? You can find the base is just the what? It's just the line of the parallelogram, right? This is the base. So all the other point is on the same parallel line. That means I can just move all the point into one part. Okay, I can move 1, 2, 3, 4 to here. Now, if I move to here, you can imagine this one is like I connected the diagonal line of the top small parallelogram. So that means this shaded area is also half of the small parallelogram. So now if I draw the similar one at the bottom, the parallelogram like here. Okay, like here. This shaded part. Okay, you can see this one. The base is also the base of the parallelogram. So we call this one dog teeth, like the dog's teeth. Okay, so this is also half. So from this picture, we can find a conclusion. So if I cut some parallelogram into several parts, you can see the half of one part plus the half of the other part. You can see the total shaded area is also half of the total. Okay, so this is very important. So yeah, here is some basic things about the parallelogram, the half model. I hope you can remember these basic things, and after that, do more practice. You can find anything else. So not only the question just give you the diagram and ask you to find out the parallelogram. Sometimes you need not only you need to find out the half model, but do some combination and calculation. Okay, so this is all the things about the half model inside the parallelogram. I think it's enough for you to do the Nemo's question, but of course the Nemo's will test a lot of new things. So for example, how about the half model inside the trapezium? So here is a trapezium. Okay, I just leave the question with you, and I hope if you have interesting, you're up here, can you try to prove why the diagram I draw is a kind of half model? Okay, so this is a trapezium. Let me copy something here. I will show you some basic half model. Okay, so the rule is, yeah, if I choose this is the midpoint, this is also the midpoint. If I connect the midpoint, the left part's area is the half of this trapezium. If this is the midpoint on this side, okay, on this side, if I connect here and here, so this shaded area is also half of the trapezium. Also, similarly, if I have this is the midpoint, this is also the midpoint. Okay, so if I connect here, the midpoint, no, actually it's randomly. Okay, so I connect this part. It's also a kind of half model. And if this one is the midpoint, this one is the midpoint. Okay, so if I connect here, yes, you can connect this part. Randomly choose one point, okay? Randomly choose. Connect here. If you connect this piece and this part, the shaded area is also half of the trapezium. Okay? So you can try to prove that if you have interesting, and you tell me, I will give you a small gift when you go to the TASMO competition. Okay, try to prove all the things. Just show me how you prove that. Okay, so here is today's topic. It's very important and useful.